for notes for pre-calculus. This is 2.7, nonlinear inequalities. And our objectives in this section are to solve polynomial inequalities, solve rational inequalities, and use inequalities to model and solve real-life problems. So let's get started with polynomial inequalities. And so we looked in detail at polynomials and finding the zeros. So if we can do all that, then this section will follow pretty easily for us. So if we have a polynomial inequality, there's one x squared minus 2x minus 3 is less than 0. You can use the fact that a polynomial can change its sign only at its zeros, the x values that make the polynomial equal to 0. And between any two consecutive zeros, the polynomial has to be entirely positive or entirely negative, regardless of whether it just touches at that zero or crosses at that zero. And so if we know the real zeros and we put them in order, all we need to know is what the sign, S-I-G-N, positive or negative, value of the y value, positiveness, I guess, of the y value or negativeness to know whether it's going to be greater than or less than 0. So these zeros are going to be the key numbers of the inequality, and the resultant intervals are going to be test intervals for the inequality. And in the end, we're going to graph these on a number line. We're not going to use a coordinate graph for this because we don't really care that much what the actual polynomial looks like. So that one that we were just looking at, x squared minus 2x minus 3 is less than 0. If you factor that, you get two zeros at x equals -1 and x equals 3. And just notice here that I have kind of a little hint. So our intervals are going to be like from -infinity to the first 0, from that first 0 to the second 0, and then the second 0 to infinity. Or if there are more zeros, we'll go between those as well. So once we have those zeros, then this gives us that interval. -infinity to -1 is our first interval where that 0 is. -1 to 3 is the second interval, and 3 to infinity is that last interval. So if we can set up a little number line, probably a good idea as we're doing this, then we can just test something in each of those intervals. We're used to making an interval table anyway, and in this case, it's even a little easier because we are just interested in whether it's positive or negative. So just kind of think about that was a quadratic, and maybe that's a parabola that's going to go like that, or maybe it's going to be a parabola that's going to go like that, or if it were a higher degrees, maybe it would go through there and kind of dance around up and down a little bit and then go back through these zeros. But that's the only place that it can change sign, S-I-G-N. And the other thing we want to remember, and so maybe I'll just pretend to draw in my axis here. And for this problem, if you remember, it's x squared minus 2x minus 3 is less than 0. And so that would be kind of a parabola that looks something like this. Ooh, that is not my best parabola. I just feel like I could do a little better. Well, that's not my best either, but it'll be good enough. And so then just a reminder, this is strictly less than. So we're going to use parentheses around those zeros in those intervals. The intervals themselves, when we make that table, test interval table, will have parentheses, but it's going to have parentheses if it's less than 0 or if it's greater than 0. And then it'll have brackets if it is less than or equal to 0 or greater than or equal to 0. So we would include those zeros if it was the or equal to. So then to solve an inequality like x squared minus 2x minus 3 is less than 0, you only need to test one value in each interval and then see if that works or not. And really, our good news is we only care if it's positive or negative, so we don't always have to find the exact numerical answer in that interval. So here's kind of um, our our decision making box. Wow, that doesn't even sound good to me, but hope you're enjoying my lack of being able to use great words. So finding test intervals for a polynomial. To determine the intervals in which the values of a polynomial are entirely negative or entirely positive, use the following steps. So it says find all of the zeros of the polynomial. FYI, you first want to get one side of the equation equal to 0 or 0 on one side of that inequality. Um, and and just by nature of inequalities, if the 0 is on the right and it's either greater than 0 or less than 0, greater than or equal to, less than or equal to, our brains kind of can process that a little bit easier. It is not a necessity, though. So back to number 1. Find all of the zeros of the polynomial. Arrange the zeros in increasing order from least to greatest. And I usually tack on negative infinity and positive infinity. These zeros are the key numbers of the polynomial. Use the key numbers to determine the test intervals. Choose one representative x value in each test interval and evaluate the polynomial. When the value of that polynomial is negative, the polynomial has negative values for all of those x values in the interval. And when the value of the polynomial is positive, it has positive values for every one of those. So let's just dive in and see what happens in our first problem. So lucky for us, this very first one does have one side equal to 0 already. So this is number 1, x squared minus x minus 6 is less than 0. So just a little note to myself, I'm going to use parentheses. Maybe I shouldn't use parentheses to say I'm going to use parentheses. I'll put it in a little box. So we're going to use parentheses when we do this one. So the first thing is to just find the zeros. So x squared minus x minus 6 equals 0. However you factor things, you're making that decision. I think this is going to be 3 and 2 minus 3 plus 2. So x equals negative 2, x equals positive 3. So then I'm going to line those up from least to greatest. So negative infinity, negative 2, 3, and infinity. That kind of just gives me right away, I'm going to know then how to set up my test intervals, in my opinion. So I'm going to need an interval. I'm going to need x values. And truly, I can either find, and I might leave myself a little workspace for this one. This will be f of x, which is y equals f of x, and this is going to be the sine of y. And then I'm going to tell you truly, sometimes I'll kind of skip that inner step and just see what happens. And I'll show you how I'll do that in a little bit. Then I need my test intervals. I'm going to get that from this information right here and just go from kind of left to right and see what happens. So I'm going to go from negative infinity to negative 2, from negative 2 to 3, and from 3 to infinity. I've crossed the entire x-axis if I use those numbers. And then I just need test values. They can be anything. So in this one, I'll try like negative 3 is there. I'll try 0 because that's always easy. I'll try 4 here. And then I'm gonna show this, maybe I'll call it the long way, and I'll I'll first put these values in, the original f of x rule that's right there. And I didn't pick super big numbers, so I think I can handle that in my head. Negative 3 squared minus negative 3 minus 6. So that is 9 plus 3 minus 6. And so that's 12 minus 6. So that equals 6. And so that is positive. And then with 0, when I put zeros in there, it'll be 0 squared minus 0 minus 6, which is negative 6. So that'll be negative. And if I put 4 in, let's see, 4 squared minus 4 minus 6 is 16 minus 4, and then minus 6 is 6. A lot of the same number, positive and negative, and so that is going to be positive. Now, just note to self, look at this factored form and think about how I could figure out whether it was positive or negative without ever doing all of that work. And this will kind of just shorten things up for you as you go. So think about putting this negative 3 in there, and that would just be a negative times a negative, which is a positive. And so I could have just said it's a negative times a negative. Oops. Which equals a positive. And I could have just known it without having done all of that work. And same thing with 0. Let me get rid of all that yellow. If I put in 0, this is positive times a negative. So a positive times a negative, and that would equal a negative. And that one would be done. And then look, I'm going to say this. Sometimes I might try something like 400, and you might be thinking, why would you use 400? Are you thinking that? Why would you use 400, Mrs. Jones? But here's why. Because I don't even have to do the arithmetic. 400 plus this little number is just going to be positive, and 400 minus this little number is just still going to be positive. And so I'm going to get a positive times a positive, which is equal to a positive. So just a little note to self, and I will be doing that from now on, not finding values, but just looking for whether things are positive or negative as we go. Back to this problem though. So in this one, we were looking for when this is less than 0, and so we want this negative interval. So really, our interval is right there, and it's going to be the same because we're using those parentheses, and so that's going to be kind of what we want. And I just don't want to write with that thick of a marker, so let me choose a different marker, but that color again. There we go. So this is going to be what works. When we give our answer, we want to be able to give it in an interval, which we have there already, and we also want to give it as a number line graph. And so I probably have a little number line graph that I could use. Let me look for. So I found for myself, at least, a nice little number line here. Do the best that you can, and it does not have to be perfect as we go. So again, we want to give our solution on a number line, and we want to give it in interval notation. So now I will say that I want a little thicker marker, and I'm going from -2 to +3, and I'm just putting those parentheses right on there, and I'm just going to shade in between those two. And that is my number line solution. And then my solution in interval notation, solution is from -2. Oh my goodness, I went from negative infinity. -2 to 3. And that is our solution either way. Kind of think about what this means in terms of the graph. And we know that's a quadratic. And so if I would graph it, -2 is someplace like there, 3 is someplace like that. It's positive x squared. So we know that that graph would go kind of like this. That would be the look of the parabola. And where are the y values below 0? It's kind of in that interval right there. So, you know, back in the day, we have done problems like that before. So, feeling kind of confident, go ahead and try this one. If you need a little first hint, you can, I'll tell that when you first look at this again, because I'm going to pause it, and then you might move on. So either you've tried this or not. If you are not sure exactly what to do very first, remember we want to get that right side equal to 0. So I'm going to add 48 to both sides. And when I do that, my new rule now is going to be 2x to the third minus 3x squared minus 32x plus 48 is less, or excuse me, is greater than 0. So think about your earlier work. Now you have to be able to find these zeros, and maybe pause this, see if you can figure out what those zeros are, and kind of using the P over Q and synthetic division, and maybe even using your function or table feature of your little calculator and see what you get. So on the side, I'll just kind of say on the side, find all zeros. And the zeros turn out to be 4, -4, and positive 1.5. Sorry, positive 1.5. And I'll leave that for you, or you can ask me sometime if you want to. And so then I like to line those up from negative infinity. Then I would come to -4, then I would come to 1.5, then I would come to 4, and then I would come to positive infinity. And I might call that 3 halves. I just might think that might be a little bit better. And this time I'm going to do my interval. I'm going to pick x values, and I'm just going to say the sign of y as we go through. So my intervals are going to be from negative infinity to -4, -4 to 3 halves, 3 halves to 4, 4 to infinity. So maybe you remember that I said I like to use the factors, and certainly I can use this rule that's written right there. But since I knew my zeros, I'm going to write those in factored form, and I'm even going to change this to be 2x minus 3, just a little easier for me to look at as I go. And so again, you can either put that 0 right in this rule, or that x value, not a 0, or you can put it in the one with the factors, and all we are interested in is the sign, positive or negative sign of y. And so when I pick my x values now, let me just make sure I can see everything that I want. Now I'm going to pick like, oh, just kidding. I'm going to pick like -100, because it'll be easy for me to figure out. Between -4 and positive 3 halves, I'm just going to pick 0. Between 3 halves and 4, I'll just pick something easy to work with, 2. And I'll pick positive 100 here. And then kind of think about my strategy, and I'll kind of make this table have like 2 little parts here. And if I put -100 in there, I'm going to get a negative times a negative times a negative. So it'll be negative times a negative times a negative, and that's going to equal a negative. I don't need that equal sign though. And then if I put in 0, it'll be -4, +4, negative. So negative, positive, negative. a negative times a positive times a negative, and that will be a positive. Be careful because they don't always just alternate signs, because sometimes they'll just touch at that and so they'll go back to the positive. Just be aware of that. And I'm getting to have kind of a lot of stuff there. So let me get rid of some of these black markings. And then if I put in positive 2, for that one, I'll get negative, positive, and 2 minus 1.5 is positive. So I'm going to get a negative times a positive times a positive. And if I use that 4 minus, that would have been maybe a little bit easier. And that will be a negative answer. If I put in 100, it's going to be positive, 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 positive times a positive times a positive, and that's going to equal a positive. And now I want to look up at the fact that I wanted this to be greater than 0. So things that have greater than 0 are in this interval and that interval. So those are going to be our solution intervals. And let me kind of just get rid of some of that yellow, and I'm going to just put a little star by this positive one and this positive one, and I'll just circle those as we go. So then I want my number line, and just keep in mind that number line is going to be kind of just like this order that we put things in right there. This time I'm going to freehand draw my number line, and as long as I get them kind of in order, -4 is there someplace, 3/2 is here, and +4 will be a little closer to that. We'll put it right there. As long as I get them in numerical order, I'm good to go. And so my solution in interval notation is this -4 to 3/2 in parentheses, because I'll just go back up here because it was strictly greater than 0. So I just wanted the positive union with 4 to infinity. And so when I graph this, I'm going to put parentheses around those and shade in between. And then for this other one, 4 to infinity, I'm going to put a parenthesis there and then kind of shade out towards positive infinity as we go. And so there's the graph of the solution and the solution in interval notation. So take a minute, try this next one yourself, and then we'll compare our answers and see what. Okay, let's see how you did. Oops, my first job is to get one side with 0 on it, and then I just found the zeros kind of quickly there, and then I lined them up from -infinity to positive infinity. Then I made my interval table, and I just tried some easy to try numbers, so -300, 0, and +300. And I get a negative times a negative, which is a positive times a negative, which is negative, a positive times a positive, which is positive. The one I want, since I want these to be less than 0, is that middle one where they're negative. I just do my number line, I write my interval, and then I shade as is. So pause this if you need to see that further, and then we'll move on. This is going to be part 1 of 2 parts. So number 4, I think, will be our last one that we do, and then 5 and so on will be in the next one. So there's this little part about unusual solutions. So let's kind of look at that. There's only 2 different rules here, and there's 4 problems. So let's think about this does not factor because there's nothing that multiplies to be 4 and adds to be 2. So let's look at the Pythagorean theorem to kind of solve this and find the 0. And the zeros will be the same for either one of those. So x equals -2 plus or minus the square root 2 squared, which is 4, minus 4 times a times c. Kind of hard to see my times there. Let me Let me do that. There we go. All over 2 times 1. So x equals -2 plus or minus. And then when we do that, we're going to get the square root of 4 minus 16 all over 2. So this is not, has no real roots. No real roots. So that's what we're interested in, these kind of problems. So it does not cross the x-axis. Does not cross the x-axis. So kind of think about what that means in terms of the graph. The parabola is a U shape because it's positive x squared, and it doesn't cross, so it's going to be everything is above 0. And so in this one, when we kind of think that through, then really it's either going to be everything works or nothing works. And in this one, we're going to say that everything works. So our solution is from -infinity to +infinity because it has to have that U shape, and we know that it does not touch the axis. And then when we graph this one, I'll just put a couple numbers on here, -1, 0, 1, 2. And when we graph that, we shade the whole entire number line. And so that's our solution for that one. This other one, we've kind of done all the legwork here because we know this information is going to be the same over here. Now, if I just draw my little picture again like this, and of course I don't know where that U is. It could be on either side of that y-axis or cross it. I don't, someplace close by. I don't really know. But when is this function going to be less than 0 or below this axis? And that's going to be never. So here our solution, our solution is the empty set. And when we look at that number line, it's just going to be a blank number line. 1, 0, 1, 2. So that's our solution. That empty set we could give, or we could put the empty set with braces with nothing in it, and that would work as well. So that is those are some of our unusual solutions. We have 2 more problems, similar in that we'll have zeros. They'll have the same zeros again. And so for this one, when we factor that one, notice this is a perfect square. And so when I factor x squared plus 2x plus 1 equals 0, I can factor that into x plus 1 equals 0. So x plus 1 in parentheses squared. Remember then, that means that x equals -1 with a multiplicity of 2. And when it has a multiplicity of 2, remember it just kind of touches there as we go. And so let's look at that interval table for this one. -infinity to -1 and then to infinity. So our intervals -infinity to -1, -1 to infinity. And we'll pick some x values and we'll find the sine of y. So for this one, if I try like -100 and +100, I'm going to get, and I'm going to look at this little piece right here. I'm going to get negative times a negative, which is a positive for the first one, and a positive times a positive, which is also a positive for the second one. So this sign is positive, this sign is positive. I want when this is less than or equal to 0. Notice less than 0 never, but equal to 0, it would be equal to 0 at -1. And so let me just draw a little number line on here. -2, -1, 0, 1, 2. So for this one, we will get for our solution, oops, not that, at -1, just that single point, and then our solution kind of an interval notation, we can't really do it because it's not an interval. Oh, I keep wanting to write 0. It's really -1. And there's our solution. So similarly, look at this next one. Same polynomial, so same zeros, same interval table, all that, but now I want that to be greater than 0. Well, think about the fact that it is positive in this interval, positive in this interval. It would be equal to 0 at -1, which we know from that previous problem, but we want it strictly to be greater than. So we get the two intervals, but we do not get to use the -1. So here, let's just draw that number line because we've done all the other work. -2, -1, 0, 1, and 2. It works in both of these intervals, but it does not include 0. So our solution is -infinity to -1 union with -1 to infinity. And when we graph that, here's our -1. We go with this this way and shade, and with that open parenthesis, and then the open parenthesis this way, and then we shade that way. So it kind of includes everything on the number line except that one number as we go. And then just a little kind of follow-up. This just kind of reminds you that you can be substituting in x values into the original or into the factored version, and things will always work out no matter what you use as long as it's in that interval. And you can use a graph to check your results if you want, sketching that, but it's not a necessity. So this concludes part 1 of notes for section 2-7.